I'll be able to send out the final draft to the authors later this tonight. So I'll just Haesung proofread like everything, so it's like very nice.
So this is the final?
Yes, I just need to confirm a couple things with you.
Okay.
Yeah. So for this, the title, we initially wanted to go with the proposed title, but there's like maximum character requirement, which is 85 characters.
Oh, okay.
But when I looked into the journal, there were some titles with like 100-ish character. So I was thinking maybe this one or the below like 85, 84 ones.
Oh, 85 characters?
Yes.
— 85 is so short.
Yes, yes.
Does it allow you I guess you can still try for the ones we said, but if it doesn't allow you to put it in, then yeah. I mean, this doesn't carry what we did. Yes.
So I don't think we can add like AI, but we can add like a spatial kind of spatial distribution to imply that we look at like slides.
So use this one if you have to do 85 characters. Okay. Short title is fine. Anything, you know, it doesn't matter what you do. Okay.
Oh, and,
what did you?
So the last time the abstract, and I would like you to take a look at the abstract and the conclusion part, which weren't like finalized last time. Oh, and also I have a question about the author. Is there the order of author? Does it matter like between like Lunit or like New Antigen?
No, it doesn't matter.
Oh,
yeah, this is fine. Yeah, just check with Lunit that this is what they want.
okay.
Yeah. Standard of care, understanding. So let's not use the company name in the abstract.
Oh, okay.
Just make it generic. So I guess the 18% comes out in the conclusion.
Yeah.
I think it has to come out in the results section.
Oh, okay.
At least the distribution between the three groups. This is methods. So make sure there's a distinction.
So they want a single paragraph for the
there's 4 paragraphs here.
So I'm just gonna like combine everything. That was what I was.
They want a single?
Yes.
And this is what journal?
Endocrine related cancer.
Oh, okay. Anyway, still, it has to be in the order of methods, results, conclusion. So in the results, you say, what are those three group percentages?
Okay. Is it okay if I add it here, this part? Just like in parentheses, like percentage? Because it will be just a single paragraph.
Okay, just for this one. Yeah. So you take out which one this goes out and so again, I don't know if this the only thing that bothers me is that this is not what we found. This is kind of speculation. This will likely have good response because of the signature, but not it doesn't always happen that way. So
No, we don't. That's why we're proposing like further investigation with the like immunotherapy on advanced PTC. That's to my understanding.
so you would just say whether inflamed signature really translate into better response in immunotherapy in thyroid cancer. We don't care about what other cancers do. It's not the purpose of our research. So whether inflamed IP is really an indicator of good response to immunotherapy in thyroid cancer remains to be seen and should be carried out in the future research. That's what you need to write. Okay.
Could I just add something like further investigation warranted for?
So it's not a characteristic showing favorable response because we don't know. We don't know that this inflamed signature so yeah, just write about the future directions rather than a hypothetical statement.
Because I was actually going to discuss one thing about like in the conclusion part, the Lunit had some studies using the other various types of cancers which showed like better survival results within the inflamed IP. So I thought that could be like incorporated in this sentence, maybe.
Here, conclusion.
No, like in the abstract, the last sentence, I was thinking we could keep this sentence because the Lunit papers, like using the other types of cancers, actually showed better PFS, OS in the inflamed IP.
Yeah, but that's another study. So
Yeah.
just write what's unique to this study. You don't have to say in other Lunit study it correlated in pan tumor it correlated with. Do you understand? What do you know if that study included thyroid cancer? Did you read the poster?
The poster, they mentioned thyroid, but I think it's very little, if there is, because they grouped it as other cancers and they listed some cancer types. But okay, so I'll just work on this sentence then.
Yeah. So did you make amendment?
No, intro method result is pretty much the same. So and let's see. Oh yeah, and could you take a look at the sentences for the result, like each paragraph, the key sentence?
Desert immune phenotype was associated with higher age, wild excluded. This is too specific. I would say make it more general. I know you are saying that in here, right?
Like different
it's
clinical characteristics.
yeah. Each distinct IP was associated with distinct clinical or clinical pathological characteristics or something like that. Same thing, you don't have to say the specifics, you know, it was linked with distinct mutational profile or something. This is okay. Why did you add this one?
Just to sum up this paragraph. Do you think I should just?
Yeah, because this is not really the theme.
Oh, okay. So should I just combine this paragraph to the above one?
This one?
Yep.
Yeah, I think it's fine.
Okay. Just...
And then these mutate, these genes are tumor suppressor genes, right?
So HRMMR genes.
Yeah. So DNA repair, they have to have a defect for the cancer to happen.
Mm-hmm.
Yeah. So it's a tumor suppressor gene.
Yeah. Mm-hmm. Yes.
So I wouldn't say oncogenic. I know mutations likely oncogenic, or I would say functional is better word. Is it a functional mutation or not?
Or like defect, like here oncogenic means defect, defective. So
It's likely.
So this oncogenic and unknown oncogenic effect is the term that the OncoKB used. So I just
for these genes?
For like in general, they classify genes or they term the genes oncogenic, unlikely oncogenic, kind of like regardless of which type.
So genes are classified into two: oncogene, tumor suppressor.
Yes.
Deleterious mutation in tumor suppressor gene can be oncogenic. Mutations were classified as oncogenic. So this is what OncoKB said?
Yeah, they just what it calls show us whether it's like oncogenic, likely oncogenic. Like I think it's a broader term that they use, not like specific to version status.
So this, did you write that in the method? How you use
The,
OncoKB to determine this?
so I just wrote the clinical implications of here. Go up a little.
Clinical implications. Gene mutations were determined. Clinical implications. Clinical implications. And you can put it in parentheses, oncogenicity or oncogenicity.
Oh, okay.
Okay, I mean, if they use the term oncogenic, it's okay, but. . That's okay. Inflamed IP at high cytolytic. That's okay. Including immunotherapy target molecules. What do you mean by that?
There were like 10 immunotherapy related molecules. If you go down a little, which I refer to Dr. Jonghan Park's paper, these were also included as this immunomodulatory molecules. So I just wanted to like mention this.
Yeah, I don't think you need to write it in the title.
Oh, okay.
Yeah. To say other IPs. Okay, what change have you made in discussion?
So actually, I tried to add this one, but I was actually asking Dr. Oak and the Looney team about how they classified it. So I found out that the JCO NSCLC paper, first of all, there's this till density cutoff and the IS cutoff. So they first like when they want to determine the immune phenotype, they first make a whole slide into 1 millimeter grids, and each grid they annotated like using the till density cutoff, which is 200, right? But for the JCO and SCLC, they used like the other 106 and like 370 something. But the papers that they published after that, they used 200. And then there's this concept named like IS score. So it's like basically the proportion of grids with immune inflamed annotation. So they use like different IS cutoffs for each papers. For example, for the ASCO paper, they used IS 20%. And the other paper with HCC, they used like 10%. And in our study, we used the 33% for the cutoff. So I wasn't sure if it's okay to add this sentence, like comparing the proportion of inflamed like samples, because it's like they used different cutoffs for each cancer so far. I mean, type of cancers.
So 18, wait. But the cutoff isn't the cutoff still same?
No. So this one for NSCLC, the cutoff is the same as ours, the IS cutoff, which is 33%, but they use the till density cutoff different from ours. So
why is that?
So I think they changed the program or the unit scope after this paper. That's what Dr. O told me. So after this paper, they're using the 200 cutoff for the studies that were done afterwards.
200. So 200. What do you mean by
So
200?
So first they divide the slide into each grids, and then the cutoff. So in order for them to call a one grid inflamed, there needs to be till density above 200. And this density is different from what this JCO paper used, which was 106 at this time. Yeah. And after that, they have this term called IS, which is the proportion of the grids that were annotated as inflamed. So that also differs. They haven't come up with a universal cutoff. That's what Dr. Oak told me. So,
but for thyroid study,
the till cutoff was 200.
and IS cutoff is what?
IS cutoff we used is the 33%. But if we want to like compare with it, I can only maybe change the change the IS cutoff to 20% if you want to like compare with the abstract, the poster, ASCO poster. If you want to compare the proportion of the inflamed tumors.
I see.
Yeah.
For lung cancer, what is IS cutoff?
So do you mind if I just share the screen?
Yeah.
Yeah.
I will stop share.
So basically, this was the first one, JCO and SCLC, which used the till density cutoff of 106 and 3 something, and the IS cutoff of 33%. The IS cutoff was same as ours. And this one, this is the ASCO poster, which used the till density cutoff of 200, which is same as ours, but they used the IS cutoff of 20%.
Oh, 20%.
Yep. And this one is the phase 2 study. This used the same till density till cutoff as 200, but the IS, they didn't have a cutoff. They just look at the correlation, like continuous IS percentage. And the last paper or the abstract is this one, the HCC. Here they use the IS cutoff of 10%. So I was thinking if we want to mention the proportion of inflamed, we can use the IS 20% just to mention that if we use the 20%, the proportion will be this, which is like 24%. I just quickly ran it. And the proportion of inflamed IP was about 24%. And it's actually not too low, actually. NSCLC is 33%.
Thyroid, no?
Thyroid was, if you see here, this one. The other cancer types included thyroid cancer, which is over here.
Oh, okay.
Yeah, and if I used IS of 20% in our cohort, it was about 24%.
24%, okay.
Yep. So if you think this is a reportable thing, I think we can just mention if we use IS of 20% and compare with other cancer types, it was lower than NSCLC. It was kind of.
Yeah, I think you can report that in discussion.
Discussion.
If we use, because our study used 30%, 33% cutoff.
Yes. Yep.
And that's how all the analysis was done. But if we want to compare with other histologies, and cite this, and you can say if we use 20% cutoff, 18% changes to what?
80%, 24, or around 24.
24, and that is kind of still comparable to other tumors, but less than lung cancer, hepatocellular, and in renal cell is, a lot of yeah, interesting. Yeah, you can so you can mention the famous ones: melanoma, renal cell, lung cancer. Yeah.
So what I thought was like we can mention that, and if somebody else, like for example, reviewers ask, should we also add it in that we use 33% because we want to look at like 3 IPs, like which seemed less arbitrary to me, like instead of using like other cutoffs. For example, I just quickly look at like using 50% for cutoff, for example, IS 50%, and then excluded 50% and the rest as excluded, like those kind of things. Like,
What is your question?
so like, do I need to explain like why I use 33% as a cutoff, or no?
I think it, but I think let Lunit give you rationale for 33%, because
They don't really have rationale, but they said like if you want to compare 3 IPs, 33% might be a good, like, reasonable.
okay, then you can say so. Yeah. Good. For our study purpose, 33% was used. But to compare with other histologies, just the IP score, then then you can describe what I just told you about this graph in the discussion. Yeah.
Okay. Yep.
Okay. Go back to the manuscript. Anything else you changed?
I just added the conclusion part. Oh, well, and the one last thing is before, just above the conclusion part in the PFS OS, this one. Should I not mention this because now I know that the inflamed IP is like based on the different cutoff value, or should I just mention in general?
It's okay. It's okay to mention. Yeah, it looks okay. Conclusion looks okay.
Should I use this sentence in the abstract as well?
It's okay. It may benefit in the, yeah. Well,
Okay.
not in the abstract.
Oh, not in
the conclusion, it's okay. Yeah, I think it's fine.
This one. It like, is this how I write acknowledgement, or?
Yeah.
Okay. And regarding the data availability, do I need to upload the Lunit score when I submit the paper?
Lunit score for each.
Like my data, yeah, like, or the classification. Other data are available publicly. I'm not sure like we have to disclose, or.
I see what you mean.
Yeah.
Yeah, I think you can make it supplemental. It's fine.
Supplemental data.
Mm-hmm.
In this case, do I just upload the sample ID and the unit classification and the unit score, or my raw data file?
Oh yeah, because you have to say mention sample ID. And I think TCGA sample ID and just the unit classification is good enough.
Not the like inflame score, the IS like percentage.
You can add IS percentage too.
Oh, okay.
Yeah.
Yes, IDs.
So where are you submitting this to?
Endocrine related cancer.
Okay. And do you have a second journal?
Not sure. There was thyroid cancer, and the one that you mentioned, I think it was oncotarget, if I'm not mistaken.
No, not OncoTarget.
Oh, because the thyroid paper you mentioned.
Yeah,
Yes.
I think thyroid cancer is next, maybe.
And then I'll have to see.
And then you can find some maybe like immunology journal, cancer immunology, or yeah, look for good ones. I'll let you search for it.
Oh, and can you take a look at the table and figure quickly, and the titles for figure. So I have 5 main and 5 supplemental.
Oh, in the figure. Okay.
Is the title for table this okay? Demographics and baseline characteristics.
Of thyroid cancer patients.
TCGA.
You don't have to write TCGA.
Oh.
Characteristics of patients with papillary thyroid cancer. Distribution of driver mutations according to IPs. So I would bold letter the title.
Oh.
And then make these are footnotes.
Footnotes. Oh, okay. I don't.
These are all immune cell, right? So immune cell types.
They have stromal cell also. Immune stromal.
And mesenchymal stem cell. Okay, then leave it as it is. This one, you need to make it larger.
Yes. So the picture, I mean, the figure itself was large, but when I like add this, it's gets smaller.
So what I would do is landscape, make it landscape rather than portrait.
Oh, okay.
That way you can,
Right.
yeah, just these 2 pages, you can make that.
Okay.
Yeah. So all fine.
Okay.
Just bold letter, the titles, and
Yes.
it's all good. Ready to go.
Okay, thank you. So I'll try to send it out to co-authors by tonight. And Dr. Oak said they have this team to help with like revision before submission. So I'll just get feedback and submit it like end of this week, if everything goes as planned.
Okay. Very good. Anything else, Myomu?
Oh, the other one is the small cell lung cancer. I asked Dr. Oak if they have the HN slides.
Yeah.
I mean the Luna score, but they say so the data is on CBio portal, but it's not part of TCGA project. And there is this ucolone or something something. Those are the authors, but they don't share H&E slides.
Oh,
So Dr.
really?
Oak was saying like if you want, you could contact them, but I think they already tried, but they didn't want to share.
Oh, really?
Yeah, so
Dr. Og asked them?
So here I'll just, as I know, the uColor dataset does not share the H&E images. You may connect with the authors if needed. That's what Dr. Oak said.
Well, and then that's the only small cell TCGA data they have?
Yes, that's the only thing that can be used. Because others, there are no data like mRNA expression and
Wow, that's disappointing.
yeah.
I guess it wouldn't hurt to ask just one more time.
Okay.
And you yourself can email the author and explain what you want to look, and they can be invited, their team can be invited as co-author.
Okay.
And then we can analyze the data together. They can offer them a lead authorship, major authorship, and we make this a collaborative effort and explain what the Lunit scope can do, and see if they can. They don't have to share the slide, but if they don't want to scan themselves, they can share slides with us,
Okay.
and
Share
they can scan,
or scan.
or they can scan themselves and share us just the picture files. Yeah, CC me and CC Dr. Oak and see what they say again.
Should I just what do you call attach Luni paper also or
Yeah,
not?
you can attach Luni paper, see what they did,
Okay.
or just to attach the poster
Oh, the
for
poster.
the
Okay.
pan tumor, because that's the
Oh, okay.
because right now no one has looked at the TIL of small cell in a I guess in that large scale.
I agree. I think it will be interesting if they could.
Yeah, just convince them, and if they want more information, we're happy to do a Zoom call with them and Lunit. Yeah.
Okay. Yeah, that's pretty much it for me.
Yeah, if we can't do TIL, then I don't think we. I mean, I know you guys did the 4 subtypes, but I don't know that 4 subtype. If you can't match it to TIL, then there's no really.
Yeah, there's no additional information with that.
Right.
So
I
Okay.
mean, you can, because you have 4 subtypes, you can at least use Excel because you have the mRNA.
Yeah, but I think I saw some like
Similar.
papers, even did GSEA with the small cell and
Hmm.
yeah.
Yeah.
Okay, so I'll try to email them.
Okay, very good.
Thank you.
Yeah. I have to answer a call from hospital, so let's take like 5-minute break. Okay. Okay, I'm back. Okay, who's next? Oh, Eugene, you're in Korean time, so you can go next.
Yeah, if you don't mind, I will give you an update about regarding HPD. I think Dr. Jian is here as well. So, it's very tough. HPD projects, we're doing so many things, but it's never ending. Always like there's something I have to do more, but I think we're almost there, but I will. So figures are already and tables are almost done, but we're thinking of doing something new as well to make the whole story more understandable. So I'll just briefly give you some updates about those things. And Dr. Jian has been a tremendous help for us. And so I'll share my screen soon. And by the way, transfusion survival narrative review has been submitted by Dr. Cho last week, and
So Liam, help Dr. Cho submit it. I don't have the account for Annals of Internal Medicine. So our default rule is chat Che lab meeting, Gmail, ID and password. Share that with Dr. Cho so that he can make an account and submit it. And then he can share, yeah, he can use that to track down where, where it is.
Sure.
Okay.
and by the way, Dr. Liam, have you ever sent the email to the oncologist for regarding double lung transplantation case report? I think I requested you to do that a few weeks ago, but just you can give me an update later as well. I'll share my screen.
So it's not submitted yet? Albert
It's been submitted since last year, October, and in the last lab meeting, you recommend us to send the email, requesting them to get back to us as ASAP. But I asked Liam to do that. I was just wondering whether you receive any email or.
I have not yet. We can follow up with another one.
So
Okay.
October and now it's March. That's unacceptable. We need answer whether they will take it or not. Usually 2 months is good enough. So yeah, definitely follow up with them. If we don't hear back within a week, I think we should abort. David, 6 months is too long.
Yeah, right. So.
But what's the
Okay.
status? Did you check the status?
When I checked it, it was with editor. Not sure whether it has changed it or not, but I will reach out to Liam or you after this.
Yeah, be persistent, check. So I want you to make a habit of any project you're involved, make a track mark of where things
Right.
are. If you don't hear back, be persistent, send email at least once a week. Everyone's busy. Same thing, if you don't hear back with me within 1 week, so keep texting me. I have so many other priorities, so I may not get back, and I might forget. So there, someone has to be there to constantly remind. So same thing with other editors. They can't hold our article forever. I mean, it's a very timely article. Everyone's waiting for it, and people are asking me, why are you not publishing? And I have nothing to tell them back. We have to be very persistent.
Yeah, sorry to hear that. But so regarding that, could you recommend other article where we can move on after oncologist? So before that, we tried JTO and it got rejected, and the oncologist was the second target. And
So was it JTO CRR?
No, it was just the JTO, I think. And I have to figure out whether JTO CRR receive case report or not.
It does.
Okay.
So you can do JTO CRR, but it's a very short article. But I'm afraid if the limitation of the words are too much, then don't do it. Not worth it. But if you can do it, then trim it down. I'll leave it up to you. But if not, the next after oncologist, you can go with there's a journal called lung cancer or clinical lung cancer, and see which one has better impact factor and which one takes case reports, and let me know. Okay.
Okay. Yeah, understood. So for hyperprogression, these are our figures. So you can everyone can see my screen, share the screen, right?
Yeah.
Okay. So main figure 1 showing how modification affect the incidence, and for both individual patient cohort and then regimen cohort.
Yes.
And this is how, again, modification affects the TGR or TGK ratio. And then we move on to the next figures showing, investigating the impact of adding the number of new lesions. So here, it shows among the patients who got progression.
Give me 1 second. Give me 1 second.
Sure, sure.
Okay, I'm back. You know, my assistant Leslie, she resigned, so Cynthia from my other office is covering me, and it's been really hectic because she's gone. It's
Understandable.
hard to find a good replacement. We're still interviewing. In the meantime, Cynthia on the other side, behind him office is covering. So, yeah, if you email Leslie, it's not gonna work anymore. So, and
If you
she did
find
not sign out anything to her incoming person, so she has no idea what to do. So it's kind of all in vacuum. She quit without signing out anything. So she said,
Oh,
"Ask check." So I don't have time to sit down and it's hard. This is how the transition is always hard. Yeah.
right.
Okay.
I hope I find someone that isn't, yeah.
Yeah.
So actually, like all the figures are, I think once I show it to you, but then we settle down with which one will be the main or like supplemental. Those are new changes. So this figure comparing non-PD, HPD and non-HPD PD, and it all like they show difference between each group. And so we move on to, but then the main point of this figure is it's actually confirming what previously has been known in other paper. So like confirmation thing. But then next figure it's kind of something that we newly tried in this paper. So we included modified definition group as well, and it shows they are different from the non-PD group, but the difference between modification and original definition was not statistically significant because of the small sample size or something else. And lastly, we try to look at whether modification can have different meaning when we classify them into someone having more than 2 new lesions or 2 or less new lesions. And interestingly, like progression PFS are still worse when people have less than 3 new lesions, but overall survivor was not different. It was only worse when people have more than 3 new lesions compared to people have less than 3 new lesions. So I think I have to explain why this difference are here. And these are just supplementary.
So go back. So in the discussion, I think you have to emphasize that 3 or more new lesion means worse overall survival. And that is consistent with 2 or more new lesions showing worse survival in the other publication. And there is meaning in, understanding what the new lesions mean, and how that the number of the new lesion or the overall burden, assessing that will help us better prognosticate. So that has to be a whole paragraph of discussion. Okay.
Sure. Okay. Yeah, these are main figures, and from here all are supplemental. So it just describing how tumor size is changing depending on including new lesions or not. And And as
Go
Dr.
back. How did you
Okay.
how did you number these?
How did I number?
Yeah.
Number. You mean the number below each next to each line?
Yeah. Is it just patient identifier?
Yes,
Yes,
yes.
it's just number of case. I mean the case number.
Hmm.
Yeah, so we four patients who has hyperprogression by Champia, they also have hyperprogression by Sarabuzit. So yeah, the colors I kind of match the
What is
color.
others then?
Others like you mean
In the second graph, you have others.
I actually didn't feel I have to.
These cases were not HPD, but they were MHPC.
Do you think I have to still like mark them as individually?
And that is same for the fourth graph, same thing.
Yes, I think I missed this thing. Yeah, I will copy others as well for fourth graph.
So I think people look at this graph and wonder what 1, 2, 3, 4, 5, 6 means. It's just a patient identifier, and they're color coded differently. So I don't think number one, I don't think you need numbers. Number two,
Would color be enough to help readers identify the change?
yeah, I think the color is enough. You don't need the patient identifier. And I don't think you need to put the label others. It's just a little more confusing.
Then what about just mentioning each line indicates each patient and in the legend?
Yeah, just in the legend, each line indicates each case.
And same color indicates same patient, maybe something like this.
No, so it's so evident, you don't have to say it.
Okay.
Because the others are same color. I think in the legend you can say as a you can at least say how many new cases were added for modified version for both Champiad and Sarabuzid. How many new lines were added according to the new definition. You can say that in your footnote.
Okay. So two things, each line indicates each case and how many patients are added according to the change, right?
Yeah.
Yeah, and these are supplemental. So we only looked at the patients with hyperprogression, whether by original or modified definition, but maybe because of the case numbers are relatively small if you look at the below. So not much difference are detected between two groups regarding PFS, OS, and similar.
So that's the message. When you write discussion, the message is not that there's not much difference. The message is modified group of patient has worst outcome, as much worse as the original definition.
Mm.
So that's why the modified version is still clinically meaningful.
Mm.
If you say there's no difference, it sounds like
Sounds like, yeah.
we're ignoring, or we're kind of saying
Downsize or
saying that it's not important,
Mm.
but it's important because their prognosis as worse as the original
true.
definition. So it is
Okay.
clinically meaningful. So just the way you write it, it's important.
Thanks. We'll definitely do that. And
I note that.
Arnie, do you have something to say?
No. I just I try to note everything Dr. J said.
And it's
okay.
recorded. Again,
Yeah.
I want you guys to record it. I noticed that it wasn't being recorded, so I clicked recording. So make sure you guys, record this.
I thought it would have been recorded. Oh my goodness.
Yeah.
Okay. Yeah. And when we even like go further, like try to group modified patients. Oh, why there's not M here? So these are just including modified patients who are detected as having hyperprogression by modification. And we try to look at whether there's difference between number of new lesions. And there's no different, although like it looks different, but because of the small number sample size, not that different. But when we included reference group, as I show you in the main figure, definitely new lesions more than 3, they had worse impact on overall survivor.
So yeah, this dilutes our message. So you can, this is supplemental, but
yes, this is
the
supplemental.
other one was the regular figure, right?
This one?
No, the other one.
Yes, the other one.
One with the reference.
Yeah, this one is main figure. Yeah.
So I wonder if you need that supplemental figure, because
Oh,
it's just
this one.
same graph without the reference, right?
Right.
So I don't think you need it because it's just redundant.
Okay.
Same, right? The other two graphs are same. Are they different?
No, same. If you compare the numbers, there's only one group, reference groups is added on top of this. I'm sorry. So yeah, definitely same.
Okay.
Okay, then we would delete the supplementary figure 3. Or should we keep it?
No, you can delete it. It's okay.
Okay. Thanks. And for table, we are still doing it, but I have to leave within 5 minutes to attend visa explaining session from Cook County Hospital. And one thing I want to ask your opinion is, I think Dr. Jian can follow up that I not presented, right? Dr. Jian, are you available?
So this is our table. We revised the table, and so something not special is that comparing HPD versus non-HPD based on each definitions. And this is a little bit same as a figure 1, but when you look at the figure 1, there are the numbers on each area, but this is the total number. So I think we should still keep this table as well. And we wanted to show them which parameters were used for each definition.
Yeah, I think that's fine.
Okay, and this is the univariate and multivariate analysis for progression-free survival and overall survival, but the court is all patients, not only patients with HPD or MHPD. This is univariate analysis, and this is multivariate analysis.
So what was significant? Can you summarize?
When we use the HPDC, the patients older than 70, then the HPD was less occurred. And
Actually, sorry to cut in, but the interpretation should be in this way. So when we include the HPDC as an independent variable, patients who have HPDC, patients who have less than older than 70, did greater. They did greater in terms of PFS than patients who are less than 70 year old, which is contradictory to the previously found previous findings, I think. It's not about the incidence for HPD, but it's about shorter PFS, like higher risk of progression. It's showing the risk of progression rather than the risk of developing HPD, and HPDC is one of explanatory variable for progression. Not sure whether this is done right way, but
well, from this table, I could realize that the significant factors could be different by which definition used. So that was the first thing. And when we use the HPDC or HPDS, commonly the brain metastasis show the significance in progression-free survival, whatever we use the HPDC or HPDS. And for overall survivor, there was not a common factor, but when we use the HPDC, there was no significant factors regarding to OS, but when we use the HPDS, HPDS didn't use the RECIST, they used only TGK, right? And then there were 4 significant factors, which is related to overall survival.
Oh, so you listed the only, like the ones that are only significant?
for multivariate only.
So number one, for both hyperprogression multivariate analysis, in the footnote, you have to say what variables were used in total. For both OS and PFS, if you used probably the same variables, that you have to say what were used. Now, because the focus is with HPD, not the liver and all that tumor So the tumor burden at baseline 90%, less than 90%. What does that mean? Can you explain?
Tumor size evaluated by RECIST criteria, and I try to set the cutoff as a 90 percentile.
So I wondered too, what is the 100%? What is the reference?
So percentile, so I kind of lined up all the patients from someone who has the maximum size of the tumor size from the least size of the tumor size. Then I cut off 90 percentile as the cutoff line.
So, I mean, that's gonna change with all the, different cohort, but it's cohort dependent. But anyway, why did you choose 90?
I tried 90, 80, 70, 60, but 90 was the cutoff that showed significant difference.
I think it's still, I know it's significant, but it's number one, it's cohort dependent. Number two, 90% is not, it's not a clinical number. So I would have to say this is rather a arbitrary cutoff. So, if you want to say high tumor burden versus low tumor burden, I would just go with above median, below median.
Okay.
Or you can have some of the RECIST as like a clinical cutoff. Like some of the largest diameter from RECIST could be, I don't know, 10 centimeter, above and below. You can just say high and low tumor burden defined by 10 centimeter above below, and that's understanding that's an arbitrary cutoff. But as long as you define that in the method section, that's how you defined high low, it's fine. I would rather have a clinical
Like the actual
cutoff, rather than 90%.
I'll try to calculate what size was 90 percentile and then maybe use the number.
Yeah. So anyway, I don't know. So higher tumor burden means worse PFS, but it looks like brain metastasis. If you have it, it's a better prognosis. That's what it says. High platelet is usually worse prognosis, but here it's better overall survival. Older age means better progression for free survival here. These are all counterintuitive, and I don't know if they're all true or not. And above all, whether it's true or not, it could be just a phenomena that we observed in this cohort. And the last point is that multivariate analysis, the focus is not on other variables. We don't care. We don't care about them. What we care about is what variables we have controlled for. So that's those variables, you just list them in the footnote. So what I would do is, rather than, because people will be confused, what do you mean, brain mets have better prognosis? They will less likely to trust our data because of the direction of association. So I'd rather not show the other variables simply because they're not our focus. So just say what variables you controlled for and just show multivariate analysis, OS, PFS, you know, to definition about the hyperprogression. And whether some variables were significant or not really isn't the focus of our discussion, and it's fine. But for univariate, you can still show what other variables that we know are important in prognostication. So still keep them in univariate, but for multivariate, you don't have to show them. That makes sense?
Understood. Yeah.
Oh.
And yeah, I'll leave right now.
Okay.
And then I'll catch up with the.
Okay, thank you, Eugene.
Okay, Chia, let's take a 5-minute break, guys.
Okay.
Okay, I'm back. Okay, Jian, we can carry on and we can have Eugene watch the video later.
Okay. So otherwise I'll just do supplementary table. I can show you quickly.
Oh, yeah, the other one, go to table 2.
Okay.
Let's say this, the regimen of immunotherapy, the right side, yeah. I don't know if this sends the right message because
Do you have any idea? It was a little bit tricky how to express.
I think I had addressed this in our last meeting. I don't know if Arnie remembers it. I think we tried to address this, the terminology and methods.
Okay, I will check again.
Yeah, I think we said something like using there's the patients versus is it either case or line of therapy or I can't remember, but we had this discussion and made some
Okay.
methods.
All right.
Okay. But all these analyses were carried out based on patient or cases?
Patient.
Patients, okay.
Yes.
So make that clear in the methods, all these.
Yes. And this is supplementary figures with the patients who were not HPD, but after that they were confirmed as MHPD. And we just wanted to show each legends, how it changed and what was the new legend. And about this, Eugene made this table with all variables. And as I remember, in table 3, there were several clinical variables, but here she showed every variables with the hazard ratio with the references. Can we replace the table 3 as with this one?
Yeah, this is.
But actually, this is too many variables included.
Okay. Tumor at baseline. So same thing. Eugene needs to correct this one.
Okay.
And above that one.
Yeah, sure.
You look at the 3 of new lesions. So that to me is too much. 1 of new lesion. No, yes. So I would do presence of new lesion. Yes, no is
Okay.
one thing. And we said new lesion 3 or above versus other. Okay, so new lesion, yes or no? 3 or more new lesions versus other.
Okay.
That could be two different categories. Yeah.
I think this is enough.
Yeah. Show me the other regular figure again. Let me compare. I think she put new lesion 3 or yeah. So she needs to change the tumor burden here as well.
Mhm.
I guess here it's more succinct. Go down. Huh. Hmm. Yeah, can you go back to,
Supplementary table.
yeah. So do you know why you got one in regular figure, one in supplemental? Because
I guess
Oh.
Eugene wanted to show all the hazard ratio
Yeah.
compared to reference. I think, yeah, I think kind of duplicate.
Yeah, it's
But
duplicate.
yes,
It's
yes.
duplicate. It is. So I need
Yeah.
you need to make this into one.
Oh, okay.
Yeah. No need for two tables.
Mhm.
Same table. So work towards making it into one.
Okay.
Okay.
And this is the same analysis, but we included only patients who had HPD or HPDC or HPDS. But patients numbers were so small. The hazard ratio and all the values were weird. So small.
Yeah. So I don't know the value of this analysis. Do you?
Because in table 3, she just performed the analysis with all patients, but we are focusing on the hyperprogression. At least we had to show the clinical variables, which is significant in patients who has HPD.
So clinically, to me, this analysis doesn't make sense. It's just a 4 patient, 11 patient.
Yes, yes,
And
yes,
with
I agree.
each small number, you're trying
Mhm.
to have outcome is PFS, OS. So to me, it doesn't make sense. What makes more sense is outcome is hyperprogression
Mhm.
outcome.
Mhm.
And then you have all these variables to say what leads to the hyperprogression.
Mhm. Okay.
But this
That
is
yes, that is in table 1.
right,
So I think we can just delete the supplementary table 3.
right.
Okay. Okay. That's right. And supplementary table 4, it shows the genomic alteration. And the AK2 amplification, AXL amp. These genes show the significance, but the numbers was only one patient in HPD group. So this result can't be reliable, but at least we can show the distribution of gene alterations. So I want to keep this.
So total 1. So the 25%
Mhm.
means what?
1/4, I guess.
1/4. 1/2. I guess it's okay to keep it as is. That's fine.
Okay. Mhm. Then that's it. That is all about the table.
Okay.
Um, I'll keep working with Arnie and Eugene. I try to finish up as soon as possible.
Yeah, so it's almost done, right? Is this
Yes, it is. And we are working on discussion part, what should be explained, and we should explain the each phenomena. So maybe within 1 or 2 weeks we can finish and we can show you the whole manuscript.
okay? Sounds good.
Yeah. Do you want to go over my project or the other people go first?
Yeah, we can talk about your project first.
Okay. This is my project. About
yeah.
the yes.
Okay, I'm back.
Okay, regarding original article, it is under review in American Journal of Transplantation. And regarding review article, it is also under review at the Journal of Transplantation Reviews. The impact factor is the 3.9. It came so below, but at least I got under review, so I'm waiting the response.
Okay.
And about the third paper. And this is also the original article, and I got the comment from Professor Younggun Che, and today I'm gonna update based on according to his comments, and I think I can share the draft to others by tomorrow. Okay, and then the timeline is submission on next week. And I will put this landmark in the manuscript. Only this landmark, not the complicated one. But I want to go simple.
So explain to us what this means.
So when you look at this graph, until 3 years, after 3 years from transplantation, recipient who had post-transplant malignant, they had better overall survivor compared to patients without PTM.
So with PTM in the first 3 years.
Yes.
So you have to make that clear.
Mm-hmm.
People, yeah, in that first 3 years or 5 years, that time frame, we're not
Mhm.
looking at PTM that happened after 3 years, right?
Mm-hmm. Mm-hmm.
So just make that clear in the method and in the interpretation. Yeah.
Okay. And when the time became 5 years, the significance disappeared, and even in 7 years.
Mhm.
But at the time of 10 years from transplantation, the significance came again, but the reverse trend showed, which means the recipient with the PTM had worse overall survivor than the recipient without PTM.
So people who do not know this project, it's very interesting. I think the year 3 is still very interesting.
Yes.
After double lung transplant,
Mm-hmm.
this is done for any indication, correct?
Sorry, again.
This is done for non-cancer indication.
Oh, yes, obviously.
Yeah. And if they develop cancer in their first 3 years
Mhm.
versus not, then they live longer.
Mhm.
Their hazard ratio is 0.79.
Mhm.
So whether this is driven by less rejection, remains to be seen,
Mhm.
but that's most likely. And I think this graph alone at 3-year mark tells us a lot. I think 5-year mark is affected by, many cancers, and cancers as they progress will, affect long-term survival because of the cancer itself being aggressive. And then also at year 5, people who's going to have rejection will already have rejection.
Mhm.
But year 3, I think tells us a lot that the immune tolerance that allows cancer to happen will allow us to prevent rejection. So I think year 3 graph is still very meaningful, but you don't have to go in depth. You just explain for
Yeah.
this article purpose.
Mhm. Mhm.
And I think you could I don't know, in the discussion you could say the further analysis on the relationship between rejection and the
Mhm.
post transplant malignancy will be addressed in another ongoing project or something, so that people
Okay.
know
Mhm.
it's separate.
Yeah. We're gonna expect the next project, which
Yeah.
is running by Hassan. Okay. And okay, I'll move on to the next project. So
Oh,
this is
yeah, I need to, the time dependent costs. Did you do that?
I did, but you recommended not to put those results in this paper. So
Right,
I
right,
just
right.
deleted it.
Yeah. But are you able to show me the result?
Oh, okay. Um, take this one. I used the PTM as a time varying covariate.
Mm-hmm.
And can I put this on? Um, I included the covariates for age, sex, occurrence of a PTM, and occurrence of a PTM was considered a time varying covariate.
Uh-huh.
And with the all cancer, sorry. Here you can see the statistical significant were all shown in every covariance, including age, PTM, sex.
Well, the outcome is survival.
Oh yes,
What is T-cove and PTM? You have both there.
T-cove is after adjusting the time dependent covariate. So that is just a kind of analyzing formula. When I put into the covariate into the time varying factor, and then the factor as made, and I use that one as an independent factor.
Hmm. So age, PTM, sex was added as covariate.
Yes.
Well, you have occurrence of PTM. So the PTM was time varying covariate.
Yes, I mean the PTM is same meaning with the occurrence of a PTM.
Hmm. Well, I guess that it's EXPB is supposed to be the hazard ratio.
Yes, that is a hazard ratio.
So hazard ratio is 0.2 or 1. I'm trying to figure out T cove and PTM, how that's different.
Oh, PTM is just the coding with the occurrence or not. And T cove is after I apply the time. How can I explain?
But because T cove already has PTM in it,
Yes.
you need to,
Delete the PTM.
yeah,
Should I need to? Okay.
because you're adjusting
Oh, okay.
variable
I
again.
get it.
You know
I
what I
get
mean?
it. Yes.
Because you already added PTM. So maybe just do age, sex, covariate, and to put time dependent independent variable as PTM.
Okay. I will make it again. But as I guess, even if I put only age and sex, maybe there would be still statistical significance.
Because right now, because you adjusted for PTM, T cove is not significant. Its hazard ratio is 1. The direction, at least the direction, is not significant. Do you need time to run this?
Oh, yes, I need.
Okay.
Yeah. Can I show you later?
Yeah.
Because this analysis is so new to me.
Yeah.
I'll move on to the next one. This is graft failure and post-transfer malignancy. Haesung now is working in the data handling, and I think Haesung can make a presentation about this later.
Okay.
And next one is radio mix. I sent the patient list to Edwin, person who is in charge in handling the image files. And Liam is still contacting him, but he didn't give any response in email. He didn't get phone, but still we're contacting him. And after we get the image files, I'm gonna send it to image trial team, and I guess I can get resist the result very soon. And then we will compare the resist result from image trial and compare with the manually calculated one. Then we can decide whether we will use this program or not. I guess we will use, but I want to validate this one. And we have
Hold on. Why does it take so long to get the DICOM file? Liam, do you have any idea?
Unfortunately not. I mean, we did request like 200 plus files. So just collecting them could take a while, but then the issue is like, we can't get a hold of Edwin. Like we've emailed him multiple times, like on a weekly basis, and I've called him like 3 times now. Yeah.
So then what's the use of having him a point of contact when before him, we used to just Yuri and us, we would just download it ourselves. So
yeah, so like the hospital policies changed so that we can no longer download the files ourselves anymore. We have to go through like this data, I forget the name, but he's like the data guardian or something, like gatekeeper. So everything has to go through him or her.
So talk to Yuri how we can get hold of Edwin, and we're getting nowhere. I mean, we just like you, Leah, make every effort to visit him in person, or him or her, whoever is in charge.
Sure.
Go to the office, knock on the door, and we emailed you many times. We want to know the work process. Is there any other form you need to us to fill out, and what's the timeline? We need the answer. We need face-to-face communication. We're not getting anywhere. I'm sure Yuri is frustrated as much as we are, because his research is all about downloading the imaging file. So ask Yuri first if he has any other thoughts, what his experience using this, if he has not had any work done through this, or if he was able to get around this, and I don't know. Find out what his experience is, find out if there's any shortcuts, find out, meet this person face to face. I think we just have to track down. Yeah.
I think his office is in Arcus, so I think we can go and ask him.
Yeah. We
Yeah,
just
I'll try.
we can't sit. We can't just sit and wait.
Yeah, I'll
And
give a visit or
okay,
And is
thank
image
you.
trial ready? Have you guys tried image trial?
Yeah, they are ready.
Then why don't you use it? Because we have DICOM files that are already downloaded.
Oh, because they asked me send the image file once with all image files, then they will put into the program.
Yeah,
Okay,
we don't
I'll do
have to
first
wait for
with
all. Just work with what we have first.
okay, okay. Mhm.
And then just play with it, learn. Yeah, just tell them, it has to be sent in.
Okay.
We're waiting, but we don't want to wait too long, so we want to
Mhm.
learn first. So we're sending first batch, and then we'll send you second batch. So yeah.
Okay, okay, I will. And Maria and Arnie, they're collecting clinical pathology data of this patient, so we can use it when they run the predictive model.
Okay.
So reference about the radiomics in this paper, which was published in Annals of Oncology, they used a 203 patients cohort, and it was so similar as ours. They used 103 patients as training set and 7 patients for validation set. And they divide the responder versus non-responder, and they
Wait. What was their cutoff? Is that 20%? No, the graph
okay.
is the lesion response. I think their cutoff is 20%. So response and stable disease, they called it responder.
Yes.
And what's the difference in color? The dark orange versus light orange?
Yes, light orange is a uniform progression, and orange color is mixed progression. Several are progressed, but several are not. And the blue one is a uniform response.
I see.
And so they divided the cohort as 3 different groups, and they compare the survivor. And about the AUC, and here I used the ChatGPT. I asked to ChatGPT what is the ideal cutoff value of AUC, and it answered this. It should be 0.7 to 0.8, but most paper, when the AUC is more than 0.6, they say that the tools are effective.
That's good.
Yeah, so we can figure out in our research. And here you can see AUC was a 0.76, 0.76.
Oh, show
So-
me graph.
Okay,
So lesions response prediction. So radiomics was better for lung lesions? Is that's
yes, exactly. Radiomix was useful in evaluating lung lesions, lymph nodes, adrenal lesions, but not for the liver lesions.
response prediction for melan. So melanoma is different.
Yes, different.
Very interesting.
But here, melanoma, still lymph node in lymph node lesions, radiomix was useful.
Hmm. The first follow-up radiomics was better. Patient overall survival prediction, uniform versus mixed and progression. Okay. Okay.
So I
Yeah.
think
So this is the first paper that looked at mixed, right?
I'm not sure that part.
Yeah, I think so, but you can look at it. But
Mhm,
when you do the analysis, you could do, because we're looking at lesion by lesion too.
mhm, mhm.
We could do similar analysis,
Okay.
saying, you know, what did our mixed group, you know, do
Mhm.
compared to other groups? So we could be a validation paper, kind of, you know,
Uh-huh.
showing what they showed, at least because, yeah, I think that's one aspect we can see.
Oh, okay. Okay. I think when I get the result, I can figure out which
Yeah.
direction is the best for our study.
Mhm.
Okay. I will.
What is
And
this one?
this is my idea
Hmm.
for our study.
Oh, the
Just-
variables? Yeah.
Yes, yes.
Yeah.
Okay, and the other one, I'm still waiting the result from the company. Last week, Dr. Lu sent the answer, but we need to still wait more.
So I know they need to check, but tissue NGS is just for validation. So if
Mhm.
they can share the blood NGS,
Okay.
then we need to generate graph and
Mhm.
yeah, have meeting. Yeah, go from there.
Right.
Because we have now what 4 months to finish.
Mhm.
Yeah.
Do you want to move on to journal club or later? I can,
Let's do journal club.
right now.
Yeah.
This paper was so complicated for me, but when I read this paper, it was kind of simple. They just described all the phenomenon. So the title was a single cell spatial landscape of lung tumor immune microenvironment. This is the abstract. They use the imaging mass cytometry called the IMC with the 416 patients with a lung adenocarcinoma, and they classified with 5 different histology patterns. And they reserved more than 1.6 million cells and they could enable this spatial analysis with all immune cells. So there were several different papers about this field, but here they used only immune cells for lung cancer. That was the point. So here's the background. Tumor immune microenvironment, they called it time, and they used it. They tried to find the spatial landscape of lung time. So here, when we look at this, this is the method. They used the 460 patients tissue from the 460 patients, and they performed the laser ablation, and with each different antibodies, they made the single cell distribution with the B cell, neutrophil, NK cell, dendritic cell, and so on. And here was the heat map of the whole landscape of cell distribution. And then after they get the single cell phenotyping, they matched to the survivor result. And then they made a predictive model, which is better to predict the cancer prognosis.
Go back.
Mhm.
Graph B is based on the CyTOF and how they identified cancer cell.
Yes, here you can see the cancer cells. About the cancer cells, they strongly express the pan-CK, TTF1, CD20. And when you look at the B cell, what was it? CD20 was strongly expressed.
Okay.
You can read like this. And here, G graph is about the immune cells, H is about the myeloid cells, I is about the lymphoid cells. When you look at the immune cells, they focus on immune cells. You can see the solid type show the highest proportion of immune cells compared to the other 4 different patterns. But about the myeloid cell, still solid pattern show the highest proportion, but lymphoid cell, there was no significance. So with this result, you can see over here, particular macrophage, there were 2 different macrophage. They divide as CD163 positive and negative. The most frequent cell type was CD163 negative macrophage. And the difference between 2 was CD163 negative was kind of a pro-inflammatory response it has, but positive has anti-inflammatory response. So among total cells, among immune cells, both CD163 negative macrophage was the most common cell type.
What is the difference between the 2 graphs?
Total cells and immune cells.
Among immune cells, okay.
Yes.
If this is total cell, is cancer is the most obviously. Okay.
Yes.
But there's T helper, cytotoxic T cells, and B cells. So yeah, and the neutrophil, there's a lot of the neutrophils too. So okay.
This is the base of study because the survivor curve showed that the solid pattern showed the worst survivor outcome. They defined as aggressive tumor type or high-grade tumor type as a solid pattern. So these authors only focus on the solid patterns, solid tumor. So here, when you look at this right side graph, graph 12, you can see 5 different patterns, but in solid pattern, CD163 positive macrophage was significantly higher, but not in the 163 negative.
Which is pro-inflammatory. Okay.
Yes. So they focused again in solid pattern tumor with the CD163 positive macrophage, not negative macrophage.
Pro M2 like. Okay. So I wanna. So for Hesong, for mucinous or lipidic growth, this is a really nice paper to learn what lipidic tumor types do. And all our, like the Myungwoo showed us, all our previous papers are looking at mRNA signatures, like using X cell. But this is actual antibodies staining proteins. So that's why this is such a valuable research. They actually used protein expression to classify cells. And they've also looked at lipidic type, which is our interest. Albert Curie was lipidic growth type. So this paper sheds light into the immune biology. And we have to cite this when we write our paper on lipidic landscape. Because what Tempest does is just mRNA. They don't stain cells to look at protein expression. So whatever we do with Tempest, we can use this paper as a reference to see what if it mimics the protein landscape of lipidic type. But anyway, go ahead. That's why I feel like this paper is a
Important.
very it's like a landmark paper.
So here, when you look at this each scale were divided as a 5 different grade. The toppest scale means lipidic cancer, and bottom one means the solid cancer. So if you look at the box number 1, here a CD163 positive macrophage was strongly expressed in solid pattern, which showed a lower survival result. And when you look at the CD163 positive macrophage in lipidic cancer, it was less expressed because it's a very light color. And about box 2, also with the CD163 positive macrophage in solid cancer, in lipidic cancers, T cells were strongly expressed together in lipidic cancer, but not in solid cancer. So they performed this partial interaction cell by cells. These are the clinical values they included. But interestingly, when we focus on these 5 different patterns, compared to lipidic cancer, solid cancer showed statistically significant with higher TC cells.
So what TC is what? Cytotoxic T cell?
Yes, CD8.
CD8, okay.
So
higher in solid. What about other, is there any difference in other clinical?
No difference between each variables, but only in this histologic pattern, solid pattern showed higher, significantly higher proportion of TC cells.
But even go back, even progression versus no progression, even high stage, low stage,
Mhm.
you know, it's counterintuitive, right?
Yes,
You
but this graph is only about the TC cells.
Yeah,
Yeah, there will be many other graphs, but they showed only TC as a sample.
okay.
And
But I
then-
guess still, when we think that more TCs will be meaning the more like better response. Yeah, it's I think it's interesting. Okay.
And about this bubble plots, it was very interesting. Each size of circle, size means the significance. If the circle is larger, that means that strong significance was exist. And when you look at these colors, female and male, they're paired, and less than 75 and older than 75, they're paired. So this each line means clinical variables. So when you look at the box 2, 8163 positive cells, go to box 2 here. Here, when you look at this, the CD163 positive macrophage were enriched in solid tumor compared to acinar type and papillary type here. And when you go to box 3 here, box 3 means that's B cell frequency with the survivor result. So if there are many B cells, the survivor outcome better with 0.00 less than 0.001 significance.
So survival high with if it's more cells.
Mhm.
This is in all is this just this is in all non-small cell, right?
Yes, all non-small cell lung cancer.
Yeah, this is really interesting because I don't think we saw that with mRNA data. This is coming from the immunohistochemistry or IF CyTOF data. So yeah, I think, you know, I've been telling you guys that B cell is really important, and it, you know, it just shows that it is playing a role. Do you know if these patients received immunotherapy or not?
I guess they received the immunotherapy because that's why they saw the immune cells in this paper. Yeah, I think so. 1 second, please. Okay, that's fine.
Well, they maybe I guess these tissue were retrieved before therapy at baseline or after therapy. I don't know. Can you go to method section and find that out?
Okay.
You can share your screen, the method section. We'll get it together.
Yeah. Primary treatment, knife cancer. So before treatment.
But to say whether they received immunotherapy or not, is it?
They don't mention about the treatment, but I guess from the surgical section and biopsy, but the otherwise the primary treatment was not applied for these patients.
What about clinical information, supplemental table 1 and 12? That might have in treatment information.
This is not the supplemental table. Or only access in online.
Yeah, because I think it's important to know
Mhm.
the survival is heavily affected by treatment. And do you remember the percentage of stage 4 in this group?
Um, so this is a supplementary. Table 12. Um,
Wait, stage 1?
this is for the validation set, I guess. They use 133 for testing set and they use the 60 for validating set.
Oh,
Because in figure, there were stage 3 and 4 as well.
yeah. Well, here it's 100% stage 1.
Yes, this is, yes, the validation court only. Here,
Stage,
they didn't mention the number.
yeah. Go down, I think.
Okay. Here,
They'll go down. Clinical pair, go down. This one. Oh, this is CN1.
yeah, this is a kind of a boundary area that they define.
Oh, okay. I think they have stage 1, 2, 3, 4
Mhm.
for the whole population, but their clinical prediction model only use stage 1, I think. That's
Yeah,
right.
here, when you look at this color, I guess more than 50% were stage 1 and 3, but they were stage 3 and 4 as well.
Oh, okay.
Uh,
So I think their
Um,
clinical prediction model is only for stage 1. So that's why immunotherapy doesn't matter here. Okay.
mhm, mhm.
And this survival is for, but this is for everybody, stage 1 to 4, I guess.
Yes, I think so. When
Okay.
I sum these patients, it become more than 200. So I guess I think.
Okay.
So here, let me see again. Box 1A and 1B shows that the higher grade histology pattern, which means the solid and micropapillary, which show the lower survivor outcomes. Both the neutrophils and endothelial cells had an increased tendency. So they said that if the endothelial cells enriched, which means progression. So they thought the higher grade histology pattern has a tendency to progress easily. And when you look at, box 2 here, in lower grade lipidic and papillary tumors, CD8, CD4, which is CD8 is the TC cytotoxic, and CD4 is the T helper cells, had a strong tendency for interaction with cancer cells. So here, cancer cell. And when you look at box 6, over CD8, CD4 T cell frequency were not associated with the progression because they were not endothelial cells much.
So box 6, I don't understand what box 6 says. Box 6 says.
Box is a square, and you can find the numbers above the square. So box A means here, box neutrophil.
The box 6 is endothelial cell and
Here,
neutrophils.
yes, here is the box 1. And here is the box 1B, and this is the box 2.
Yeah. So the box 6 in your slide, it says, despite the fact that overall CD8, CD4 cell frequencies, I don't know what that means.
Maybe I missed some more sentence.
Okay, you can look at it later. That's
Okay.
for the sake of time.
I found the whole sentence. This is a whole sentence.
Oh, low-grade lipidic papillary tumors, CD8 and CD4 T cells had stronger tendency for interaction with cancer cells than high grade. Despite that's figure. That isn't that a diff box 2? That's a so that's box 2.
Yeah, here compare box 2 versus box 6 they describe. This is about box 6.
Oh, that's box 6. Okay. Despite the fact that overall. I don't know if that's box 6 because that's neutrophil and endometrial cell. But anyway, you know, it's okay. Let's move.
Okay. So there are so many information about every boxes.
Mm.
Do you want to read everything?
So let's just look at B cell.
Okay.
Box 4 is telling us there's B cell and there's CD163. That's M2. Is it that's M1 like pro-inflammatory? Oh no. Is it? It's M2.
M2. Yes.
M2 and 163 positive is M2. So B cell and M2 go together in this box. B cell exhibit greater tendency to interact with M2
In high grade tumor.
despite the observation that B cell frequency was indicative for prolonged survival. Okay.
Yeah. So they use this time population with the survivor outcomes. Like for example, when they saw Ki-67, if the Ki-60 is higher, they showed the worse survivor outcomes.
Mhm.
And they saw every factors like HIF1 alpha. If this factor is higher, then also the survival outcome is worse.
So what is high here? Vascular. High grade? High means what here?
Oh, HIF1 alpha.
And low is new.
Not neutrophil. Oops, sorry. This one.
So that graph is just the HIF alpha high low.
Yes.
Okay.
And here again, they described again about this bubble plot. And this is the area that they defined. They made almost a 26 boundary, but they defined this CN1 as a tumor boundary, CN2 undefined like this. There are so many lists on here.
Okay.
And they saw each area was consisted of with each with which cells. So here, when you look at this tumor boundary, obviously cancers are enriched, but there wasn't any B cell, very strong blue color. And for the CN2 undefined lesion, there were no, let's skip this. CN3 pan-immune hotspot. There were so many immune cells, but not the B cells or the cancer cells. So they made this all to make a predictive model. And here, B cell, about B cell. And gray refer to B cell enriched neighborhoods, which means the CN7, CN11, CN21, and CN25.
Mhm.
And they saw the B cell is effect to over survivor. And anyway, the conclusion was that if there are enriched B cell, it shows the better survivor.
Okay.
The conclusion was all consistent. And they run the deep learning process with the all clinical outcomes. So go. I just want to show the conclusion here. With the clinical variables or cell frequency and or the linear markers or with the all markers. Here about the spatial information, predicted progression with a 95.9% accuracy form with the lineage markers. But when they put all together in the predictable model, it was still, it showed still high accuracy rate, but it was not better than the lineage markers. So which means each B cell or each T cell, each TH cell, that already enough to give information about the clinical outcomes.
Yeah, that's interesting. We would think that the clinical variable will
Yes,
add to it, but if you add it, it's not any
did
better.
not boost. Yeah. It's
Huh.
interesting.
Yeah. Lineage marker, when you say lineage, does it mean it has special
Each
information?
cells.
So what's the difference between cell frequency and lineage markers?
Cell frequency is just a value. The lineage marker means each cells with the
Where it is? Where?
yes, with the boundary and with the other informations.
Like a CN group? Okay.
So I guess that this was their conclusion.
But this is really high.
Yes, I don't know how to make this predictable model, but it was so good. The research was so good.
So they're predicting progression. I mean, because this is all stage 1?
Oh, both. Testing set, they had a stage 1 to 4 all, but in validating set with 60 patients, they were all stage 1.
And they predicted recurrence.
Progression, yeah.
Okay, next slide.
Sorry, I think this was the previous version.
Show me the next.
Yeah, sorry. I thought I showed you a previous version. Because I made some more slides, but I can't find them right now. Sorry. Can
So
I find it again?
what is this one?
That was the model that they explained about the predictable model. How do they learn the deep learning?
Can you show me the paper that
Yes, okay. So the almost everything I showed you, but when you see this predictive model.
Yeah.
This was the previous one I showed you.
Yeah.
And about each vector's accuracy is almost more than 85%. And here about the boundary that they defined, CN21, CN12, this in this area the accurate were high.
CN21 alone, and is it you adding CN12 and 2012? Try to understand what that thing is.
CN means that the boundary, they were so complicated, but they defined each territory in the tumor.
Yeah, right here. Next.
Okay.
This one.
Yes.
Oh, this is just a characteristic. Yeah. But I'm sure they had a definition and
Oh, here. Okay. CN.
maybe this one,
This one?
yeah. Yeah, this one is how they made 30 different. Yeah.
So here, CN21. Enriched TH cell and T regulator cell. And CN12,
Is it
this
in
territory had CD163 positive.
and dendritic cell? So I'm trying to understand when they made this territory, it shows the interaction between the cells, how they made into numbers, because it's hard to use the special information. But so the reason why they made CN is to reflect special information that these two cells are combined together.
Here.
Cellular neighborhood.
Yeah. They want to do spatial analyze in the tumor, which means according to the space, which is space, the distribution of cells will be different.
Yeah. So show me the last figure.
Okay.
AI. Yeah, this one again. So just using CN21 alone, 85%, 12 alone, 89%, 23 alone. But if you add up 23 and 20, then you get to 93%, which is amazing. Just
CN23 and CD20, not CN20.
oh, CD20.
Yeah.
That's B cell.
Yeah.
So that, is better than, you see, just get the CD20 and CD68. 68 is macrophage. Well, what is it?
monocyte.
Monocyte. Okay. So understanding cellular neighborhood adds a lot in terms of predicting.
Mhm.
What cells are next to each other is very important information we will never get if we use mRNA alone or even CyTOF alone. But if we do cellular neighborhood concept, I mean, this 93% is amazing. That it's the clinical implication is that you do the staining and you put in AI and you put these variables, they're enough to tell us with 93% accuracy
Mhm.
that this patient is going to have recurrence or not after stage 1-2 tumor resection, which is crazy. In our our clinical models have never performed this well. This
Yes.
is AI using the special the cellular data. So I think people think this is too good to be true.
Mhm.
We need to replicate this, but obviously you have to stain all these cells.
Mhm.
So that's a lot.
Yeah.
So that's why this paper is so important. But
So
at
when
least,
you look at CN23,
yeah, it's
they don't have TC or TH.
mhm,
They have the others, mast cell, NK cell,
Mm.
monocyte. But when we look at together with the B cell, even if there wasn't B cell,
right,
then the accurate rate go higher.
right. So I think there's a lot of randomness here because it's 100 sample, right? And it's 60, and then it depends on how these were all, but it's 200, is it? Oh yeah. So what's the training and validation? What are those numbers?
133 and 60.
Mm. So they made prediction model based on that, and then well, I guess then they use 60 stage 1 patients.
Mhm.
Yeah. So I guess for our research purpose, we're not able to do this because we don't have that information, but I think the future direction with LUNIT is that at least the monocyte macrophage type M1, M2, B cell, CD8, CD4 are at minimum, we need to stain these cells and let LUNIT figure out where they are, and then by doing staining, and then come up with a better LUNIT score. And then this is stage 1, and stage 1, there's not many people who recur. Most of them are cured.
Yes,
To
yes.
predict who's going to recur at 93% is crazy. But anyway, immunotherapy is much more complex than understanding who's going to recur or not. So we might not achieve this much accuracy. But still, with this, even stage 1 patient, no one receives immunotherapy. But just understanding that immune cell special distribution, even without clinical information, can help predict
Yes.
recurrence is huge. I just think that it's mind-blowing to see that prediction. with the help of AI. Because
And I guess B cells are more important than T cells.
B cell is maybe more important than T cells. So I think that's kind of a direction we need to head. Like look at these cell signatures. And, you know, I think for breast cancer research, same thing. We should look at the LUNAT score, but if we are able to have unstained slides, we should stain B cells, M1, M2. That's going to tell us whether the breast cancer will recur or not. And we should stain them and let AI determine where, you know, what the cellular neighborhood look like. Are they together? Are they not together? I think that's more important than just looking at the concentration, because we're only able to do that through mRNA or IC if we just reduce it to percentage of cells. We're not able to predict better. So this is a proof of concept paper that yes, cellular neighborhood is really important, and that can be only achieved by doing CyTOF. And we can do that with LUNAT. I know we don't have bandwidth to stain all that, but LUNAT does. So I feel like the future direction is really have capacity to stain all the important cells and know the cellular neighborhood, special information. That's the kind of the future going ahead. But at least with mRNA, this is relevant for you, Haesung. The B cell signature, M1, M2 signature, monocyte signature, these are very important to look at separately. And maybe we should come up with an integrated, you know, we have a score for each pathway and weight them in a different way so that AI can figure out, you know, how they can play a role in predicting recurrence, response to immunotherapy, and so forth. So we could at least learn that concept here. Okay, very good. I you know, I thought this is a pivotal paper, so I want all of our lab members to read and learn. Okay. Okay. Haesung.
So I have the dark papers ready. Oh, what was it ringing? All right, so I finished. Sorry, why is it
Why is it
ringing?
echo?
Can you hear me?
Yeah.
Okay. Yeah, so I have BAC, bronchioloalveolar carcinomyopathy, and also desmoid, and revolver, I'm like halfway there. Would you like me to print it out and show it to you, or do you want to see it right now?
Yeah, let's print it out and do it together.
Okay, and then for the transcriptomics, I think I told you before that we only have like we have less than 30 patients currently, but we're trying to add more patients who don't have any molecular data. And Jen got back to us last Friday that she's going to work on it. So we're still waiting to hear back from her, and that should increase our number, but I don't think there's any guarantee though.
So what is this project again? Proteomics?
Oh, this is the mRNA transcriptomic project that we were initially planning to do, trying to like validate the oncocyte, determine IO, but then the Tempest and oncocyte genes, they didn't really match. So it doesn't seem like oncocyte is gonna work. So first of all, we're trying to, yeah.
Is that final? Is that oncocyte said they cannot do it?
I will confirm once again. That's the general message I got, but I will confirm with stats and other people. The final email, I think, was very negative, but I will check.
Liam, are you involved in this too? Do you remember what happened?
I'm gonna have to check the emails again. So Haesung, did they get back to us on that? They said they're gonna look into.
Okay, I'm also getting confused. 1 second.
So anyway, I want them to say finally, because it's not the total 30 genes, we're not able to do it. Or even if with 28 genes, we will make it happen. I need their final conclusion, okay?
Sure.
If they say no, we will not work with OncoSite, at least on the mRNA project. But we will work with Tide and any other publicly available signatures. It doesn't have to be Tide, but you can definitely use Tide, and there are many others that people have used. So
Yeah, there's Impress, iPress. The thing is, like, I wasn't able to. It didn't seem like a publicly accessible tool. Does that mean should I like contact the authors about like getting access?
Tide is publicly accessible, right?
Tide is available. Yeah, so we tested with TCGA and it worked.
I don't know if Impress was made based on melanoma patients.
Yeah.
So if we're using lung cancer, we need to find the lung cancer signature. But anyway, number one is validating existing signature, but number two, we can come up with our own signature. How do you do that? You responder, non-responder, and you have mRNA genes, and you do the heat map, and you generate your own signature and find out what are the genes that are important. You do it with 20 genes, 50 genes, whatever makes sense. There are different ways to do it. Dr. Myungwoo and Dr. Iser has done it with proteomics. So you can apply the same methods. What are the genes that are different, responders, non-responders, and get the gene lists with the significant p-values, and then to create heat map with it, and you can sort of make signatures, different signatures, and then you can do it. I know you have a limited patient number, but the making a signature out of it and see what pathways are turned on, or that's another way to do it. But anyway, you think how many patients are we talking about?
I have to go through again because I didn't exactly have the right definition for first line, second line, third line. But if we include any line of therapy, then it's like around 23, because some patients were tested for their mRNA after they started immunotherapy. So I think I would think that you would have to exclude that, right? And that was about 7 patients from what I remember. So yeah, like 23.
Yeah, I'm a little disappointed that the number's too small.
But those are only from patients who have molecular findings. So that's why we asked Jen if we can have the data from patients without molecular findings.
What do you mean by molecular findings?
The DNA mutations. When they ran XT, only patients with significant DNA mutations were on the patient portal, and we could only download that data. The patients without any significant molecular data weren't listed on the patient portal.
I mean, the XT data would have something. I don't know what you mean by significant data finding.
Or like, I mean, those patients would have to have something on their DNA, like mutation reports. If they had none, then those patients were excluded from the data set. We just can't download their report.
So I think the question is, even if you don't have reportable DNA assay result,
Mhm.
you still give us the raw file of the
Yeah.
mRNA expression. You can ask that question.
Yeah, that's exactly what I did.
Okay. And it doesn't have to be, quote, my patient. It could be any Northwestern patients
Mhm.
who received the immunotherapy and who has mRNA expression data. That's all we need. Did patient receive immunotherapy? Does patient have mRNA expression data? But obviously they don't know who received immunotherapy or not, because it's on us to figure that out. So anyone with the non-small cell lung cancer diagnosis who has mRNA expression is the data that we need. I don't think it's 23. I think it's more than that. So
Yeah, of course.
yeah, so keep working on that.
Okay. Besides that, I have the graft failure PTM like association projects going on. I will show you what I have done so far. This is an abstract that we submitted a couple weeks ago about the inverse relationship between PTM and graft failure and how that affects the survival outcome in solid organ transplant patients. This is a table I made so far, just the recipient characteristics. We have a bunch of in this data set. I'm not going to include all of this. This is just like, I'm just not sure like how to represent BMI or in like a what way we should represent this. And then with race too, I'm going to erase these numbers, but maybe we could just do like white, black, Hispanic, Asian, other, something like that. But these are just minor details I could also discuss with Dr. GM or something else. And then I also listed the graft failure numbers and PTM numbers, death numbers on the table. This is not mine. I got it. I just Dr. Jian also helps me find this paper, and I thought this table was like a good reference to have. So in this one, I'm gonna compare the recipient characteristics with whether or not PTM occurred or not. And then on table 3, I'm planning to compare the characteristics with graft failure versus without. The same format. And then table 4, compare, that's not true. So this is not true. So just, not exactly how to go about this, but yeah, just try to, or no, actually I do know, like people who have both or not, both without, just basically a table that compares these two and find the association. And then do a landmark analysis, find the overall survival. I was planning to group patients, the graft failure page, or the patients who received organ transplants into graft intact and graft fail or lost. And then do like a specific survival analysis, graft survival analysis. And in this case, divide the patients into death censored versus death uncensored. And censored would mean that even if that would mean the patients, if death occurs while graft is still functioning, it's not counted as graft failure, but uncensored would mean death while graft is still functioning. Or like even patients who die while their graft is still functioning would still be counted as graft failure. I don't know. That's what I got from my research with my solid transplant papers.
Graft survival, that's death while still functioning, that's censored. Death while graft still functioning. Death uncensored. What is your question here?
Oh, I'm just giving you sort of the outline and get
Uh-huh.
your feedback.
Oh, you're gonna create graph with death censored and uncensored?
I mean, I'm not, when I looked at previous papers, they would sometimes do this kind of analysis because it's kind of unclear. Sometimes they would include patients, they would count, patients who die even when the graft is still functioning as graft failure, whereas some papers would not, and the other papers would try to differentiate the two.
Oh. Okay. Yeah, do it, whatever other papers have done, but we can see it what makes more sense. But to me, death while graft cell functioning is censored. Is that, if you know death has nothing to do with the graft function,
Mm-hmm.
but sometimes it's unclear. Sometimes the data is not clean enough to say that. So yeah. So see what others have done and replicate, and we will choose in the end what makes more sense.
Okay. And then this was what Dr. Jian suggested as for tables and figures. Do you have any feedback?
Yeah, and I think you need table with the time-dependent Cox analysis. Anything else?
That's all for now. Unless you have any other feedback.
Okay. Very good. Liam, I'll touch base with you in the afternoon. I have to go to the next meeting, so we'll wrap up here. Thank you, everyone.
Thank you, Dr. Chen.
Thank you.